So welcome back, everyone. Hope you guys had a nice 5-ish minute break. We'll try to make sure, again, this first day we go through a whole lot of different things. So um, I think, most study groups won't be, will be around an hour, but this time's a little special. And then, so we're going to go through Python next. And then we will have office hours available too. So office hours are optional. Though I do ask that you all at least attend one per week, just to kind of check in, see how things are going and stuff like that. Kind of helps me out too. All right, but we'll go into Python next. So let me go ahead and share my screen again. And I want to see if I can. No, I like to see all your guys' wonderful faces, but whenever I share, I can only see 4 faces at a time, which makes me sad. So that's okay. All right, can I change this? Nope. I see one person's face. Okay, I'm just going to have to deal with seeing 4 people's faces at a time. All right, y'all can see my little notebook that we left off at. Thumbs up if you can. Yeah, okay, I see some thumbs ups. Cool. All right, so we're going to continue on. So we finished about command lines and we're talking about Python. So Python, if you remember this notebook, we're talking about the tools of data science, right? So Python is a very common tool. Now, we will explicitly be using Python throughout the whole course. I will note that there is a programming language called R. Has anyone by chance done R before? Maybe if you were analytics or from another. Oh, I see a couple hands up, see thumbs up. Cool, awesome. So note that we won't be using R, but it's actually a great thing if you're interested to kind of learn and kind of play around with it. It's definitely different from Python. It's very useful. I will say is that you do not, if someone says to me hey, do I need to learn R in Python, or, is one better than the other? First of all, I would say you don't have to learn both of them. Unless you feel like you absolutely need, talk to someone who's at a job that you really want, someone who's in a position that you want to be in, and say, hey, this company only uses R and we only hire people who learn R. It might be worth actually learning that. But in general, I would say no, you're probably fine learning one or the other, which is a little change now. I would say in the past year, I would recommend more and more people to learn Python. Not because R is worse, but just because there's a lot more Python focused jobs now in data science. And that's just kind of the reality it is. It has been increasing. Before, I would say a couple of years ago, I'd say, oh yeah, Python or R. And now it's pretty much, yeah, I would say Python, which makes me feel good because I've been using Python for a while now. So, but just to kind of a quick note on that. So Python is a programming language. Note that we are going to explicitly talk about version 3 because version 2, as of, I believe, oh man, I know it's outdated, but I want to say when it was, but it is now officially not supported anymore, Python 2. So if you have learned Python in the past, maybe a few years ago, 4 or 5 years ago, and you're using Python 2, that's how I learned, that is not supported anymore. You should definitely look at Python 3. And there's subtle differences, but for the most part, they're pretty much the same. There's just some small things. So something to note. First, I want to talk about some best practices when we're doing coding. So a quick kind of show of thumbs, if you guys don't mind, who's done some coding before? And I'm pretty sure some of the R people have kind of said that. Okay, cool. I see some thumbs up. Just keep it up just so I can get an idea. Okay, cool. No, that helps a lot. So it looks like quite a lot of people have had at least some kind of coding experience before. And I know you guys probably had pre-work in the boot camp prep stuff. So you're at least introduced to it. But it kind of helps a little bit to talk about this, especially coding practices, because data scientists are notorious for not being good at writing good, clean code, which you all will not because you are my students. And so you will all have beautiful code and everything. And I pride myself in that. But for reals, though, is that the reason why we talk about coding best practices is that we talk about what is the goal of code. And the code is really, when you're writing it, is to read it more than you write. If you're writing so much of it, it's easy to get yourself into imagine when you're if you, I don't know how long it's been since someone's read a 5-paragraph essay, but back in school, if you wrote a 5-paragraph essay, if you could technically write a 5-paragraph essay just off your mind, right? And just write the whole thing. But you'll probably if you proofread it, you're ooh, there's some not just typos, but also logical flow that just doesn't make as much sense. Technically, gets the point across, but it's like, it's kind of inconsistent. Maybe you have some grammatical issues, or, maybe your argument doesn't quite make sense in the essay. That's kind of like the idea with code, is that if you take some extra time to like really think it through first and then write it, it's going to be a lot easier and trying to proofread it afterwards. And code is very different because it's logical in the sense that, like, if you write your code wrong, it just won't run. But there's some practices and stuff that can kind of help you make sure that you might write something called good, clean code, right? And one of these processes, kind of like standards, is called PEP8. So this PEP stands for Python Enhancement Proposals. And PEP8 in particular is basically like a style guide for Python. And so I've put a little link here. I'll send you guys a link right now on Zoom chat and everything. But the main idea is that it's like some conventions, like, is it necessary for everyone to like follow this exactly as necessary? No, like some people will break from it and stuff like this. But the idea is trying to write very clean code that's understandable across, from not just from like individuals, but also across multiple teams. So if you pick up code from somewhere else and start using that, you'd be able to understand it and know, like, it's a little bit easier to read and stuff like this. Don't feel like you have to read. Like, you can see how long this thing is. Like, this is pretty long, but it's worth kind of like looking it through. So you can see things like, like, do you use tabs versus spaces? In general, usually spaces is better for Python because we use white space and all that stuff. And you can see like how many blank lines in there. Now, in reality, I will tell you is that like almost no one in the industry follows PEP8 to a T. Like, no one does that, right? Some companies will have specific style guides. For example, I put a little here, other standards is Google's style guide is actually really good. And if you follow this one, for example, it'd be really nice. And I know Google internally does a lot of really good, like, clean code, because literally like their whole code base is available for everyone who writes code at Google. So it kind of makes sense. And they have very specific things of like what they do that might differ at least slightly from PEP8. And just kind of know, like if you read through one of these, like if you followed one of these standards, you'd be more like, you'd be better than probably like 95% of code that's out there. And if you follow like four, like if you just look at this and like follow some of those things, I would say you're better than probably 60% of all data scientists writing code online, because some of that stuff is tough to read because it's just a huge mess of things. It's like the person who wrote the 5-paragraph essay just so in one go versus like really thinking it through. So at doing this, it's not going to make your code work better. It's just going to make your code a little bit easier, which in some senses is better because you can actually understand it. And one thing I like to joke is that I write clean code, even if it's just for my own project, even if it's just me who always see this, I try to write clean code because I like to joke is that I am working on a team, past Victor and present Victor. And the things that past Victor does really upsets me sometimes when he messes up, because I forget like what past Victor was doing. And I say, what were you doing, past Victor? And past Victor is nowhere to be found. So I like to try to keep extra notes and stuff like that. And we'll talk a little bit like what that looks like. But I think it's a good kind of way to like think of like when you're writing code is always think like someone else is going to look at it, and that you shouldn't just assume, well, I know what I'm doing, because I've had situations, especially where I've done contract work. I was with the same company, and I literally had the company go like, hey, like, remember that stuff you worked about, like, like 6 months ago? And I'll be like, yeah. Like, could you think you could like take that up again and like finish that up, or like do these enhancements? And thankfully, I'm pretty good at like documenting my code and like writing really good code, that I was able to look at it, because I was like, I don't remember anything I did. Like, I have a pretty bad memory, and is able to work on that stuff. And that happens all the time. So it's a good thing to kind of keep in practice. So even if you're just writing your own code. And then of course with teams, it's like, yeah, like make your code readable for other people to read, because people will let you know. So some good practices. I'm gonna just kind of read these off and then we'll go through it one by one. Readability, functions, which I know we haven't talked about necessarily. Does anyone have, in the pre-work, could you guys do functions in the Python code? Okay, see some, that's cool. So we'll talk about that too. And then security in general. So first thing is readability. So you'll see this right here. It's like no magic numbers. A magic number is kind of just like a number that's associated sometimes with a variable, but doesn't really tell us like what. For example, like we can see here, n visitors and average children. Those variable names are like, oh, I understand, like at least maybe in the context, like, oh, it's n is the number of visitors, right? 5. And average children. Oh, the number of average children, right? It's like there's some context on there. A and B, that's kind of tough to be like, maybe in some contexts it might make sense, but a lot of times it's just like a variable, right? It's like, I don't know what that represents. It's just a like variable attached to a number, like why is this 3, why is this 2? And then even having like this like x, which is not really descriptive, but even if it's descriptive and having this 3 times n visitors, why is it 3? Like, I don't really know like what's going on here. Is the 3 because of some preference we have? Is 3 referring to some other variable that we decided not to write down? Like, that's the kind of thing that you want to avoid, is that you want to be able to basically like read your code, like in that line as a sentence and say, oh, I understand what's going on here. Where we know this is 3 times visitors and it technically will work, but like if this 3, for example, represented like, I'm just going to say like, oh, the number of visitors is like number of visitors that are going to this theme park ride. And for every visitor, we need to have 3 seats on a vehicle, you know, for this visitor. Like, maybe that makes sense in some context, but like, what if now we say, oh, we need 4 now? It's like, we have to go find where that 4 is versus like, okay, let's say like number, oops, n seats per visitor. You go 3 like that, right? And then this is a little more readable now. And so now if I need to change, like, oh, we actually need like, you know, 5 seats per visitor, I can change that now and understand in context, like, ah, that's what I mean. Okay, does that make sense to people? Okay, so this is to avoid magic numbers. All right, variables, since I kind of mentioned that, is in general in Python, I actually messed this up right here. This should be lowercase n, but that's okay. Variables are lowercase and snake case. So we tend to keep things in lowercase. The reason why is just basically out of convention. It just makes it easier for us to like know, like, oh, this is just a variable. Snake case is this underscore. In Python, you can have, how do I say this? You can have underscores, you can have letters, and you can have numbers in your variable. You can start any variable with either an underscore or some letter, but you can't start a variable with a number. So this would not be a variable, but something like this would be a variable. So would this be? Okay. So those are the kind of rules. So variables, lowercase, snake case, mean these things. And that means that Python tends to, if you have another programming language that you've done before, Python's variables tend to be very long, sometimes takes like the whole page and whatnot. And that's okay. Of course, within reason, make it readable, but like if it's a little bit long, that's okay. Classes, we haven't talked about classes, but no, when we talk about classes like objects, you tend to start it with a capital. So if you say something like, you know, later on we'll do like linear regression, which is a class, you'll see something like this, like, oops. So that'll start with a capital. So that's why we don't start our variables with capitals, because it's reserved for something called a class, which we'll talk about in the future. Okay, and then constants, you'll sometimes see things like, oops, sorry, I realized I didn't have that set up. You can have something like all capital, like n seats, something that's like not going to change. You could have something like that. So that way, you know, it's like, oh, this is like a constant that's not going to be there. Common ones like pi, for example, you might have something like pi or whatever, or some other constant, so you don't have a magic number just floating around in your code. Okay. All right, and then internal use, note that I kind of said you could start with an underscore. Usually though, that's reserved for internal use variables that like other coders who are reading your code shouldn't necessarily see. That's kind of vague, but just know it has to deal with object-oriented programming and classes, which we'll talk about in the future. So in general, you shouldn't start with this unless there's a specific reason why you're starting with an underscore. If anyone, has anyone learned like Java or C++ or something like that before? Okay, I see a couple thumbs up, cool. In Java, like this would be equivalent to like a private variable or a private class. So that's kind of nice. Though just know this is not actually private. It's completely accessible. It's just kind of like notation wise. Like, oh, it's private, so don't look at it. Don't try looking for it, but it exists here. Okay. Yeah. Anyway, use meaningful variables. So like I said, don't use like letter A or B unless that has a specific meaning in the context. You should try to name your variables with some like what it represents. You can also end things off with like average or mean. So for example, if you had something like, you know, visitors average like this, like we'll use that in data science a lot, right? So this way you can see what the thing is and then think, oh, it's the average or it's the, you know, mean or whatever it is you're looking at. Okay, sound pretty good? Cool. All right. Any questions at all? All right, cool. All right, functions. So I won't talk about too much about functions because we're not going to go into full detail yet. We'll see it in the future if you haven't already seen it already. But functions allow you just not to repeat yourself. So that way, you're basically, if you went back into old school programming, it would be called routines. It's the same idea. It's basically it's like, oh, you're doing the same thing over and over again. So you don't have to copy and paste your code. If you find yourself, which happens a lot, copying and pasting your code a lot, it probably means you should make a function instead of copying that same exact code and changing a couple of things. What's nice is that if you write your function name, when you actually write your function, say what it will do. So for example, calculate average number of children. That would be the name of your function. And that way you know that function's, oh, this function calculates the number of average children, whatever it is I just said. Use instead hard coding relationships. See, this is talking about past Victor says things and present Victor forgets what he's talking about. Use instead of hard coding. Oh, so the idea here is that if you use a function to calculate something, instead of you, like, for example, if I did the average, you might do something like, you know, n visitors, you know, whatever's like 100, and then say n days equals like, let's say 10, and say, oh, n, let's say visitors average equals n, n day, n visitors divided by n days. There we go. Okay, like you could code this yourself, right? But in some ways, like this is not as preferred because you have to read what's going on that one line. It might be better, and again, I don't worry too much if you haven't seen functions or not used to functions. I would say like define calc average. This is a poor variable naming scheme, for example, but that's right. And I'll say like days and say visitors. I don't know, put something like, here's my doc string. Don't worry too much if you're not familiar with all this stuff is going. I'm going to return visitors divided by days. And so the reason why I would do this, well, can I ask, why would I do this instead of the way I first wrote it? You might think of a good reason. Because it'll give me the same answer, right?
Reusability.
Reusability, right? So I don't have to like keep copying like basically this thing somewhere else, right? I can change it and like do calc average for something else, right? So I can make completely new variables and put that in there. There's another thing too, is that sometimes you can kind of edge cases. For example, let's say do n days divided by 0, right? And maybe in some cases this kind of makes sense. Like maybe I count from 0, right? So it should be like 100 would actually be the average. But if I do this, right? Oh, I'm actually, wait, did this right? That worked too well. What am I doing here? Oh, haha. This is why coding live is fun. There we go. I get an error, right? Oh, days. Wrong error. Now I get an error. Divide by 0, right? So one thing I might do is like, oh, like I actually want to catch that error. I might say like if, this is not the best way to catch errors, but I'm just kind of giving you guys an example. If days equals 0, return visitors. So I might want to have this extra functionality in here. Like maybe I realize later on versus like I have to go find and actually change this around and stuff like that. It makes more sense for I have this specific functionality tied to the function versus me writing that specific code. Okay, so that's also the other reason too. So you can add functionality more easily versus like trying to write it all at once. So good reason. Okay, cool. So last thing is security. So this is actually an important one. This won't be relevant to us until we hit the second half of our phase. But don't hard code your passwords or API keys. Okay, we'll talk about like importing them. API, we'll talk about what APIs are, but basically anything that is like a password-esque kind of thing, never copy and paste. I should never be able to see a password in your code. Okay, and I will tell you, there are, because especially if we're putting things up online, like on GitHub and stuff like this, there are literal bots and like people design scripts that will literally try to find things that look like passwords in API keys. We'll talk about API keys in the future. And try to find those and use those. So you'll see things like, if you look in like tech news stuff, people say like botnet or whatever, like, found API keys for AWS. And this happens every once in a while to even the seasoned developers and stuff like that. That's why it's good practice to like, I'm going to own right now. It's like, whenever you have to put an API key or a password, like think twice, like say, hey, like, is this going to be able to be seen by someone else? And I don't mean like saying, is the code going to be seen by someone else? But it's like someone using the code, will they see this password and whatnot? And the answer is yes. Stop and do the right thing. And if you don't know what the right thing is, ask, right? Don't feel afraid of that. This will be important when we talk about APIs and stuff. And you guys know what AWS is? Amazon Web Services? Not so much. Basically, it's a cloud provider, if you don't know, basically from Amazon. And you can set up an account and basically have like a computer running your code, right? Which is pretty cool. But usually you have to give like, API keys and stuff like that, saying, okay, like I am who I say I am. Not anyone can run this code on my thing. And they charge you, relatively small amounts. Cryptocurrency people really like finding, I mean, not every cryptocurrency person, but some people who are not so care about the legality of things will find API keys that people put on there and then use their instance on AWS to actually mine Bitcoin or whatever it is, and like basically run a huge bill. Like, so this has happened to people, even with seasoned developers and stuff like that. So just always be careful with that stuff. I just bring it out here. We don't have to worry too much about that. Like even in this phase, we're not going to be using any of those API keys, but I wanted to emphasize that now because it's so easy to get yourself stuck into that. Okay, cool. All right.